All right, we're doing the 2D motion problem with the coyote. So our coyote's originally going 8 meters per second east, and they then move to 8.8 meters per second due south 4 seconds later, and it wants us to find the x and y components of the coyote's average acceleration during that time and the magnitude and direction of the coyote's average acceleration during that time. Okay, so we have vector values, and what we want to do is we want to do some motion problems. But in order to do motion problems with vectors, we got to do a little bit of a flashback here. So let's flash back to another video quick. All right, so we have our plan. So our plan is this. We're going to start with our vector. We're going to break it into an x component and a y component. We only want to know how much of it goes in the x, how much of it goes in the y. So I have to resolve it, this is called, when I split it into those components. I can then do any math I want, whether it's just adding them or whether it's motion equations, like our equations on the sideboard, and then I can put things back together and I can combine those components back together. So, whew, that guy's shirt was impressive. So what we have to do is we have to resolve our vectors into components, do all of our math, our 1D motion, and then combine them back together. And so that's what we're going to do here. So our first step is we have to take these two vectors and resolve them into our components. Now the nice thing is they aren't at an angle, so it's all in the x direction. So v naught x is positive 8 meters per second and vx is 0. It's not moving at all in the vertical direction at the end. V naught y, initially it's not moving in the vertical direction at all, it's only in the horizontal, and Vy, the final velocity, is all down in the y direction, so I get -8. Now when I list my variables, because it's 2D motion, I'm gonna need both an x and a y, I run into a situation where I see V naught on both of them, so I need to indicate that one of them is gonna be the x component and one of them is gonna be the y component. So what we're gonna have to do is we're gonna put an extra subscript on our initial velocity, final velocity, and acceleration in both these categories. What this then means is we also need to include that subscript in our equations as well. So this is going to be a little different for us because we just got used to listing our variables and not caring about two directions and keeping them separate. So you got to work extra hard at remembering to put all these subscripts in to make sure you know which variable you're talking about in that equation. All right, so let's fill in some information we have. So initially we are moving at 8 meters per second in the x direction, 0 in the y. At the end, we are not moving in the x direction, we are moving in the negative y direction. And this all occurs in a time period of 4 seconds. You'll notice we don't put an x or a y on our time because time doesn't care. Time is the same for both. So we just need to find these two components of the acceleration. So just the same as v naught x and v naught y are the components of the initial velocity, ax and ay are the components of the acceleration. All right, and we're going to assume it's a constant acceleration. Otherwise, we can use an average here, same difference, because this is the average acceleration equation. We just rearranged it. All right, so let's cross things out. That's 0. So that was 0, and over here this was 0, and we just need to solve for our acceleration. So ax is going to be the negative v naught x over t, so I have -8 divided by 4. So ax comes out to be -2 meters per second squared. I could write this, because it is asking for this specific one, as 2 meters per second squared west. Okay, and for the y direction, so go ahead and solve that. So I have my -8.8 divided by my time, which was 4, will give me my ay. And so ay comes out to -2.2 meters per second squared, or 2.2 meters per second squared south. All right, so now I have those two components. Part B wants me to put them together, so I need to combine them back together. So what I'll do is I'll draw those two components, find the magnitude by using the Pythagorean theorem. I get 2.97 meters per second squared, and use the inverse tangent function to find my angle. Notice I'm not including the negative signs because I'm just looking at my triangle here. I will determine the relative direction at the end, and so I see I get 47.7 degrees. And how would I describe this direction? Well, my angle touches my vector and it touches the west directions, and this is on the south side of west, so this is south of west. So there's our example for how we set up a 2D motion problem. We're going to get more involved in this later on, but this is kind of the general basics. List those variables. If you have anything that's a vector, you have to resolve it into components to split it up, do all of your algebra, and if you want to put it back together at the end, or you have to, you can do that as well. Okay, there you go.